Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss cleansing agents. Actually, previous classes, cleansing action of soap has been discussed. I have discussed cleansing action of soap. Here I am going to discuss about the detergent, means cleansing agents. Here I will discuss about detergents. Two types of detergents are used as cleansing agents. These are soaps and synthetic detergent. These improve cleansing properties of water. These help in removal of fats which bind other materials to the fabric or skin. Here important thing is that these soaps and synthetic detergent improve cleansing properties of water. These means soaps and synthetic detergent help in removal of fats which bind other materials to the fabric or skin. Correct? Fats actually bind other materials to the fabric or skin. Here glyceryl ester reaction I am telling you that how it is formed. Then it is formed from glyceryl ester. Glyceryl ester of esteric acid, that is called actually fat. Fat is a glyceryl ester of esteric acid. Then this fat means glyceryl ester of esteric acid plus NOH, sodium hydroxide, 3 molecule. It will react and it will form sodium stearate plus glycerol. Glycerol is also called glycerine. Then what is the structure of glyceryl ester? Glyceryl ester of esteric acid. Now I am telling you. Actually here you know that this glycerol is the trihydric alcohol. Correct? Then this glycerol, also called glycerine, is formed from glyceryl ester. Then here also there will be a chain of 3 carbon, means CH2, CH, CH2, and from all these carbon COO, C17H35 is attached or will be attached. With first carbon CH2, COO R, actually ester means what? COO R should be there. One CH2 that will treat as a R, and other R, other alkyl, that will be C17H35, and COO will be there in the middle. That is called RCOOR ester. Then here with first carbon oxygen will be attached, oxygen of COO. Another oxygen is attached with double bond with carbon. Correct? COO, in that one oxygen is joined with double bond with carbon, and other oxygen is joining CH2. Correct? And this C-double-O, that carbon is joined with C17H35. C17H35. Okay, actually due to this it is called stearic acid. C17H35 COOH. COOH acid is there, then COOH will be there. But this C17H35, this is actually stearic acid. Then now that there are three carbon chain, then with first carbon that COO R is attached, and with second carbon, that is the CH, again same thing will happen, COO R will be attached. Then here R means C1735. Third carbon also same way, COO R will join with third carbon. Means now glyceryl ester of stearic acid, also called fat, now its structure will be CH2 with this carbon, O is attached, and that carbon is attached with COO, and that carbon also attached with C17H35. Same things is with second carbon and third carbon. Means each carbon chain, that COO C17H35 is attached with all three carbon. Okay, then this reacts with NOH, sodium hydroxide, 3NOH, because you are knowing 3COO C17H35 is there, means alkyl group in can tell. Then obviously this bond, this CH2O and O bond, CH2 and O bond will break. Then how will it break? Then it will break in the presence of NOH. Then now here what will it give? See, NOH is there. Then NOH is there. Then NOH means it will give Na plus OH minus. Na plus OH minus. Three molecules are there. First to think for only one molecule of NOH. Na plus OH minus. Then here when bond will break, CH2 and O bond will break, then you know obviously O will get negative charge and CH2 will get positive charge. Correct? Then now that CH2 will get positive charge and O will get negative charge. Then now NaOH. Then NaOH, Na is positive, OH is negative. Then negative OH will go to the positive carbon, CH2. After breaking the bond, that CH2 will be positive, carbon will be positive. Then OH will join there. Then now we will get CH2OH and bond has broken. And with that oxygen which is negatively charged, sodium will join, Na plus, that will join there. Then you will get C17H35 COO Na, because with O negative Na will join. Then you will get C17H35 COO Na. Correct? This is actually sodium stearate. Because C17H35 COO is there, with that Na is attached. Then its name is sodium stearate. And like that way, other two bond also will break. Second carbon is CH, with that oxygen is attached. Then again same way it will break. And for the second carbon also OH will attached, and Na will go to the second COO. Correct? Like that way, third also that bond will break. Again like first, that CH2OH will form and O will join with Na. Means you will get 3 molecule of sodium stearate. 3 molecule. 3C17H35 COO Na. And other product, every time OH is attached with carbon, then now we will get CH2OH, CHOH and CH2OH. Means that is a trihydric alcohol called glycerol. This is the second product. And glycerol is also known as glycerin. Then this I told you that ester, glyceryl ester of stearic acid on reaction with sodium hydroxide, 3 molecules of sodium hydroxide, it gives 3 molecules of sodium stearate and 1 molecule of glycerol. And now already you know, many times I have told what is the soap. And soap is the salt of salt of sodium and potassium of long fatty acid. Long fatty acid. Soap is the sodium salt or potassium salt of long fatty acid. Then here stearic acid is a fatty acid. Fatty acid. And 3 molecules you got sodium acetate. This is actually soap. This is called soap. Sodium stearate now here you got is a soap. Okay. Soaps are the detergent. Actually, detergent is also soap. But difference now I will tell you later on. What is the difference in soap and detergent? But you understand now. Soaps are the detergent. Okay, it is also detergent. Soaps are the detergent, but little difference is there, I will tell you. Okay, just to wait. Soaps are the detergent used since long. Soaps used for cleaning purpose are sodium or potassium salts of long chain fatty acids. Example, stearic acid, oleic acid, palmitic acids. Soaps containing sodium salts are formed by heating fat. Already I told you. Soaps containing sodium salts are formed by heating fats with aqueous sodium hydroxide solution. Fats means here glyceryl ester of fatty acid. This reaction is known as saponification. Means reaction of glyceryl ester of stearic acid plus NOH. This is called, this reaction is known as saponification. In this reaction, esters of fatty acid, esters of fatty acids are hydrolyzed and the soap obtained remain in colloidal form. It is precipitated from solution by adding sodium chloride. If you add sodium chloride in this colloidal solution, then it will be precipitated. Soap will be precipitated. Okay, it is precipitated from the solution by adding sodium chloride. The solution left after removing the soap contains glycerol. The solution left after removing the soap contains glycerol, which can be recovered by fractional distillation. Only sodium or potassium soaps are soluble in water. Remember, only sodium and potassium soaps are soluble in water and are used for cleaning purposes. Generally, potassium soaps are soft to the skin than sodium soaps. These can be prepared by using potassium hydroxide solution in place of sodium hydroxide. If it is sodium, then it will be hard. Okay, and it is that soap where sodium is there, it is used for cleaning of cloth. And if potassium is there in the place of sodium, then it is used for bathing. That is called bathing soap. One is for washing soap if sodium is there, and if potassium there, then it's called soft soap. That is for bathing purpose. Okay. Then just like in the place of NOH, if you will take KOH, then you will get soft soap, means potassium salt of stearic acid, bathing soap you will get. Now types of soaps I am telling you. Basically all soaps are made by boiling fats or oils with suitable soluble hydroxide. It is a common. Okay, basically all soaps are made by boiling fats or oils with suitable soluble hydroxide. Variations are made by using different raw materials. Many types of soaps are there. Then I am telling different types of soap. Toilet soaps. What is the toilet soaps? Toilet soaps are prepared by using better grade of fats and oils, and care is taken to remove excess alkali. Color and perfumes are added to make these more attractive. Soaps that float in water are made by beating tiny air bubbles before their hardness. Soaps that float in water are made by beating tiny air bubbles before their hardening. Air bubbles may be there, small teeny air bubbles, and that you will get. These bubbles you have to remove. Then soaps that float in water are made by beating teeny airs or tiny airs, anything you can spell, air bubbles before they are hardening. Next is transparent soaps. Transparent soaps are made by dissolving the soaps in ethanol and then evaporating the excess solvent. Okay. Transparent soaps are made by dissolving the soaps in ethanol and then evaporating the excess solvent. Now next soap is medicated soaps. Medicated soaps. In medicated soaps, substances of medicinal value are added. In some soaps, deodorants are added. Deodorants are added in medicated soaps. In medicated soaps, substances of medicinal value are added. In some soaps, deodorants are added. And now next is the shaving cream, shaving soap. Shaving time we require soap. I am talking about that. Shaving soaps. Shaving soaps contain glycerol to prevent rapid drying. Glycerol is used in shaving soaps. SHAVING. Shaving soaps contain glycerol to prevent rapid drying. A gum called rosin is added while making them from sodium resinate, which lathers well. You know that shaving soap will give you leathers. How it is giving leathers? Too much? Then for that purpose, a gum, GUM, a gum called rosins is added while making them it from sodium rosinate, which lathers well. Okay, lather is due to sodium rosinate. Okay, due to that lathers well. Now next soap is laundry soaps. Laundry. Laundry soaps contain fillers like sodium rosinate, sodium silicate, borax and sodium carbonate. You remember, laundry soaps contain fillers. Examples of fillers, then first filler is sodium rosinate, second is sodium silicate, third is borax, fourth is sodium carbonate. Now soap chips. Soap chips are made by turning a thin sheet of melted soaps into a cool cylinder and scraping off the soaps in a small broken pieces. Again you listen. Soap chips are made by running a thin sheet of melted soap onto a cool cylinder and scraping off the soaps in a small broken piece or pieces. Broken in pieces. Soap granules. Soap granules are dried miniature soap bubbles. Okay. Soap granules are dried miniature soap bubbles. Now next is the soap powder. Soap powder. Soap powders are scoring soaps. What is this soap powder? Then soap powders are scoring soaps. Contains some soap. A scoring agent means abrasive. Abrasive. A scoring agent means abrasive. Example of a scoring agent, that is a powdered pumice or finely divided sand, and builders like sodium carbonate and trisodium phosphate. These are abrasive scoring agent. Then soap powders and scoring soaps contain some soaps. A scoring agent as powdered pumice or finely divided sand, and builders. Builders examples are sodium carbonate, trisodium phosphate. Okay. Then how you will get soap powders, I told you. Okay. Soap powders are scoring soaps, contain some soaps. A scoring agent such as powdered pumice or finely divided sand, and builders like sodium carbonate and trisodium phosphate. Builders, what is the role of builders? Builders means sodium carbonate and trisodium phosphate. Builders are make the soaps act more rapidly. Builders make the soaps act more rapidly. The cleansing action of soap already I have discussed in previous classes. Now here that simply I am telling you that reaction of soap. Soap means here sodium acetate, C17H35 COO Na. This, if you will take 2 molecules of this soap, means sodium acetate 2 molecules plus calcium chloride. In water calcium chloride, magnesium chloride will be available. Then it will react. It will react with calcium chloride or magnesium chloride. Okay, I am talking about reaction. Why do soaps not work in hard water? That explanation now I am telling you. Why do soaps not work in hard water? That reason I am telling you. Hard water contains calcium and magnesium ions in the form of calcium chloride or magnesium chloride. But calcium ion and magnesium ion should be there. Or hard water contains calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride. Hard water contains calcium ion and magnesium ion. Hard water contains calcium and magnesium ions. These ions form insoluble calcium or magnesium soaps respectively. Okay. When sodium or potassium soaps are dissolved in hard water, means you have taken either sodium salt or means sodium salt of fatty acid or potassium salt of fatty acid, means soap. If soap you will use in water, hard water, then this soap plus calcium chloride or magnesium chloride, anyone you can take as example, both will react. Then sodium from the soap will come out. Okay, because you have taken 2 molecules of soap, then 2 Na plus will come out. 2 Na plus will come out. And Ca will go in its place. Calcium has 2 positive charge. Na has only 1 positive charge. Hence 2Na. 2Na is equivalent to 1 Ca. As 1 Ca has 2 positive charge. And 2Na means 2 positive charge. That's why 2 sodium can replace with 1 calcium. And it will form calcium stearate. When sodium was there, then it was forming sodium stearate. But now calcium went there. Then now 2 stearate atom, 2 stearate ions will, that is a negative stearate ion, will attach to the Ca++. Then it will form insoluble calcium stearate. It is insoluble. This calcium salt now it formed, that is called calcium stearate. It is insoluble in water. It will settle down in the water. Now see soft, somewhat soluble soap, now it became insoluble soap. That is the calcium stearate. Okay, and other product will be NaCl. 2 sodium came out from the 2 molecule of soap, and in calcium chloride 2 Cl was there. Then this 2 Na plus and 2 Cl minus, it will form 2 NaCl. Then see this now this is the reason why soaps not work in hard water. Correct? Because it will form insoluble calcium stearate. It will settle down in the water. Okay, then only water will react with soap. It has not reached to the cloth. It has not reached to the cloth. Only there before reaching to the cloth, only calcium and calcium magnesium present in water, that reacted with soap and it formed insoluble soap. Insoluble soap of calcium stearate. These insoluble soaps separate as a scum. You might have seen while cleaning the cloth. These insoluble soaps separate as a scum in water and are useless as a cleansing agent. In fact, these are hindrance in good washing. In fact, these are hindrance in good washing because the precipitate adheres onto the fiber of the cloth as gummy mass. Okay, these sodium stearate, correct? This precipitate adheres onto the fibers of the cloth as gummy mass. That's why it will not clean the cloth. And when you are taking bath, that time what will happen? If you are taking bath with hot water, then hair washed with hot water looks dull because of this sticky precipitate. If you are washing with hot water, then there also this calcium and magnesium will be there, and again you will use the soap, then same thing will happen. First water will react, hot water will react with soap, and in the hot water calcium magnesium is there, then same way reaction will take place. It will form insoluble calcium or magnesium stearate, it will form. That's why it will not clean the hair. Then hair washed with hot water looks dull because of this sticky precipitate of calcium stearate. Dye means color. Dye does not absorb evenly on cloth washed with soap using hot water because of this gummy mass. If you want to put color on the cloth, then there also dye does not absorb evenly, means not in a uniform way. Dye does not absorb evenly on cloth washed with soaps using hot water because of this gummy mass. Now I am going to discuss synthetic detergent. Synthetic detergents are cleansing agents which have all the properties of soaps, but now you listen. Synthetic detergents are cleansing agents which have all the properties of soaps, but which actually do not contain any soap. Just to remember, synthetic detergents are cleansing agent which have all the properties of soaps. They have properties of soaps, but which actually do not contain any soap. This is the difference. Now just further you understand. These can be used both in soft and hard water. Synthetic drugs can be used, that is the characteristics. It can be used in both in soft and hard water. Why? As they give foam even in hard water. Some of the detergents give foam even in ice cold water. This is again characteristics of detergent, synthetic detergent. Then there are three types of synthetic detergents. Synthetic detergents are mainly classified into three categories. First is anionic detergent, anionic, negative charge. Second, cationic detergent, positive charge. And third, non-ionic detergent. No ion will be there, neither negative nor positive. Non-ionic means what? You will think for organic, okay, or neutral. Then first I am talking about anionic detergent, means negative. Anionic detergents are sodium salts of sulfonated long chain alcohol or hydrocarbons. Correct? Remember, anionic detergents are sodium salts of sulfonated long chain alcohols or hydrocarbons. Here see, no long acid In soap you have seen long chain of fatty acid, but here you are getting alcohol, long chain alcohol or hydrocarbons. Hydrocarbons. Okay, no fatty acid. This is the difference. Alkyl hydrogen sulfate formed by, listen here, alkyl hydrogen sulfates formed by treating long chain alcohol. When concentrated sulfuric acids are neutralized with alkali to form anionic detergent. Then here you see you are using long chain alcohol. Correct? Long chain alcohol and sulfuric acid, concentrated sulfuric acid. Okay. Then alkyl hydrogen sulfate, that is the example of detergent, anionic detergent. Alkyl hydrogen sulfate is the example of anionic detergent. And how it is formed? How is it formed? Then alkyl hydrogen sulfonates formed by treating long chain alcohols with concentrated sulfuric acid are neutralized with alkali to form anionic detergent. Why you are using alkali here? Then because you are using concentrated acid. Then if excess acid is there, then that will be neutralized by alkali. You know that acid will be neutralized by alkali. Okay, and you will get anionic detergent, that is the hydrogen sulfate. Similarly, other example, alkyl benzene sulfonates, both are sulfonates only. First one I told you alkyl hydrogen sulfate. Now I am telling alkyl benzene sulfonate. In the place of hydrogen, now it is benzene. Then second example is alkyl benzene sulfonates. Correct? Alkyl benzene sulfonates are obtained by neutralizing alkyl benzene sulfonic acid with alkali. Okay. Reaction is a simple reaction, only molecule chain is long. Lauryl alcohol, Lauryle. Okay, lauryl alcohol. Then you will take this alcohol plus H2SO4. Then here what will happen? That OH from the alcohol, means lauryl alcohol, will go. This OH will go in presence of acid H2SO4. H will go from H2SO4. Then what you will get? What will be remaining? HSO4, 1 minus will be remaining. Then this 1 H plus and OH minus, it will go as water. And negative hydrogen sulfate will join with in the place of OH. There it will join. Then you will get lauryl hydrogen sulfate. Okay, means lauryl alcohol is CH3 CH2 whole 10 CH2 like that way, 10 CH2 will be there. Okay, then CH3 CH2 whole 10, again one more CH2, from that CH2 OH is there, then it is alcohol. Now when react with H2SO4, then this OH will go, and in its place that hydrogen sulfate will join, because H plus from the H2SO4 and OH minus from alcohol, they will form water and will go, and in the place of OH minus, HSO4 minus will join, hydrogen sulfate will join, hence you will get detergent, that is called lauryl hydrogen sulfate. Okay, lauryl hydrogen sulfate. Now these things here SO3H, one H is there. One H is there that you want to remove it. Means excess acid you have to remove. Then now next step you have to treat with NOH, base. Then now what will happen? This H, one H, H2SO4, 2H was there. Then one H first time gone. Now one H is remaining. Then that H plus NOH, that OH minus and this H, both will form water. And in the place of H plus now Na plus will come. Then now we'll get sodium lauryl sulfate. That is actually the anionic detergent. Anionic detergent. Second example I am telling you that you will take do-decyl benzene. Do-decyl benzene. What is this do-decyl benzene? I told you that time that from hydrocarbon also will get anionic detergent. Then here do-decyl benzene is a hydrocarbon. Then what is the formula? Then here actually with benzene ring long chain will be joined. That is the CH3 CH2 whole 11. CH3, that is also alkane. CH3 CH2 whole 11, it is joined with benzene. Then now you got CH3 CH2 whole 11 and it is joined with benzene. Correct? Then this is actually do-decyl benzene. Then this will react with H2SO4. Then same thing will happen. Now you know that H2SO4, from the H2SO4, if OH minus will go, OH will go as OH minus, then what will remain? Then it will remain what? SO3, H will remain H2SO4. Then one H and one O is going as OH minus. Then HSO3 will get, but it will be plus because OH is going as minus. OH minus. Then if it is going as OH minus, the remaining other part will be plus, means HSO3, that will be positive charge. You remember. Then here from the benzene ring, do-decyl benzene, from the every carbon one H is there, you know, that will go as a H plus, and OH is coming from the H2SO4, OH minus, it will go as a H2O. Then now that carbon become negative, and this remaining part of H2SO4, HSO3, that is the positive, that will join with negative carbon. Hence you will get, means SO3H will join to the benzene, which was negative carbon, there it will join in benzene ring. Then you will get do-decyl benzene sulfonic acid. Then here again SO3H, one H is there, means it is acid. You want to remove this H, then you have to treat with NOH. Then NOH, that OH and this H will go as water. Then now in the place of H, sodium will join. Then now I will get CH3 CH2 whole 11 benzene ring, and other side SO3 Na, means sodium do-decyl benzene sulfonate you will get. Means at alpha position, at ortho position, SO3 Na is there. SO3 is negative, Na is positive charge. And at para position, CH3 CH2 whole 11 is attached. Okay, in benzene ring. But you know that do-decyl means already this long chain is attached. Now this how H2SO4, OH band and other part joined, I told you. Then now finally after treatment with NOH, you got sodium do-decyl benzene sulfonate. Now In anionic detergent, anionic detergent, the anionic part of the molecule is involved in the cleansing action. This negative ion part will take part in cleansing action. Okay, this is the, that's why this it is highlighted as an ionic detergent, because this part will take part in the cleansing action. Sodium salt of alkyl benzene sulfonates are an important class of anionic detergent. They are mostly used for household work. Anionic detergents are also used in toothpaste. You remember, anionic detergents are also used in toothpaste. Question is asked. Now second, that is the cationic detergent. Cationic detergents, cation. Cationic detergents are quaternary ammonium salts of amine with acetates, chloride or bromides. Okay, here again I am telling you, cationic detergents are quaternary ammonium salts of amines with acetate, chlorides or bromides as anions. Means acetate will be anion, chloride will be anion, bromide will be anion. Then these actually, what is the remaining positive charge, that is the cation, that will function as a cationic detergent. Okay, cationic detergents are quaternary ammonium salt. Then ammonium salt is positive, that will function as detergent. Okay, then cationic detergents are quaternary ammonium salts of amines with acetates, chlorides, bromides as anion. Cationic part possesses a long hydrocarbon chain and a positive charge on the nitrogen atom, just like NH4 ion, you know, like that way. Then positive charge will be there, just like NH4Cl is there. If Cl will go as a Cl minus, NH4 will remain, but only difference is that in the place of NH4 is there, then in the place of H, long chain hydrocarbon will come. That is the only difference. Cationic part possesses a long chain hydrocarbon chain. Cationic part possesses a long chain hydrocarbon chain and a positive charge on nitrogen atom. Hence, these are called cationic detergents. Now, example I am telling you, cetryl trimethyl ammonium bromide. You remember, cetyl trimethyl ammonium bromide is a popular cationic detergent used in hair conditioner, shampoo, you know, shampoo. That is hair conditioner, there it is used. Again I am telling you, cetyl trimethyl ammonium bromide. Then here see, trimethyl, 3-methyl group is attached. Correct? Because in ammonium 4H was there. You remember. Then cetyl trimethyl ammonium bromide is a popular example of cationic detergent and is used in hair conditioner. Okay. Now, means here is, if you want to see the structure is N is there, with one N, one hydrogen replaced with CH3, CH2, whole 15, means CH2, 15 times. Then that is attached in the place of H, long chain, CH3, CH2, whole 15, alkyl, alkane it is attached, alkyl group. And other 3H is there, with that 3H methyl group is attached. And then this whole is a positive charge. And outside bromide is attached, anion, just like NH4Cl. Then one out of NH4, 3H is replaced by 3-methyl group, and fourth one is replaced with long alkyl chain. Okay, cationic detergents have geometrical germicidal properties. Germ, it will kill the germs. Germicidal properties. Cationic detergents have germicidal properties and are expensive, means costlier. Therefore, they are of limited use. Okay. Now, third one I am telling you, non-ionic detergent. Non-ionic detergent. Non-ionic detergent do not contain any ion in their constitution. One such detergent is formed when stearic acid react with polyethylene glycol. Remember, stearic acid is a long chain. Already I told. Stearic acid, that is a CH3, CH2, whole 16, COOH. Okay, this is a stearic acid. CH3, CH2, whole 16, COOH. Correct? Then see, when you will keep all the carbon together, then it will be 17. See, correct? CH2 17, if all carbon will write one place. But here you are writing one CH3 outside. Then CH3, CH2 whole 6 and COOH, that is required essentially. This is the stearic acid. Then stearic acid plus alcohol. If these two will react, means acid and alcohol will react. Then here which alcohol is there? Then ethylene glycol. Ethylene glycol is dihydric alcohol, you know. CH2OH and again one more CH2OH is there, and both CH2 is attached by single bond. Means CH2OH again CH2OH. Okay, valency is completed for valency. Then here you are using polyethylene glycol. Polyethylene glycol. Okay. Then here poly means n, a small n number. In polymer you have seen a small n. Repetition. Then what is the formula for polyethylene glycol? Then because it is 2 OH will be there, it is sure short, because it is dihydric alcohol. This glycol is dihydric alcohol. Then 2 OH will be there. One in the first end, other will be the last end. And in the middle CH2, CH2O, whole N will be there. It will be repeated. Okay, CH2O, whole N. It will be in the middle. It is the repeating unit. And both end, first end, second end, OH will be there. Means you can tell one end OH, in the middle you can write CH2O, whole N. After that again CH2OH. Two more CH2 you can write, then OH. Second right side. Left side only one OH. Then now you can see stearic acid COOH is there. Carboxylic acid. And here OH is there. Then now you are understanding what will happen. One side OH is there, other side H is there. Correct? Then H and OH will join as water. When OH will go as OH minus, then carbon will become, leaving part will be positive, and H from the acid side, it will go as a H plus. Then remaining part will be negative. Then negative and positive both will join. Then chain will be long. That is actually now no negative, no positive is there, because both are organic compound. That's why this is called non-ionic detergent. Then you have to not write only, all things will carry down. from the COOH. You have to write the stearic acid formula. COOH is there. Then you remove that H, and that O actually, that H has gone as H plus, then O is negative. That negative O will join with carbon because OH went as OH minus. Then carbon will be positive. Then this negative oxygen will join with the carbon, positive carbon. Okay. Then now again all things will be same. All molecules will be the same. Means CH2, CHO, whole N will be there. Again 2 CH2 is there, that will be there. And the end OH is there. Then this compound actually is the example of non-ionic detergent. It is just like ester, you can tell. Ester because COO is there in the middle. One side stearic acid, then that side CH3, CH2 whole 16, that is just like a R, alkyl group. And this side also just like a alkyl group. Then now this liquid dishwashing, you might have heard, liquid dishwashing detergent are non-ionic type. For the dishwashing in kitchen you are using detergent. That is called actually dishwashing detergent. It is a liquid form. Then liquid dishwashing detergents are non-ionic type. Mechanism of cleansing action of this type of detergent is the same as that of soaps. These also remove grease and oil by micelle formation. Action is through micelle formation. Already I have discussed how micelle is formed. Then this detergent it remove grease and oil by micelle formation. Question is asked. Main problem that appears in the use of detergent is that if their hydrocarbon chain is highly branched, then bacteria cannot degrade this easily. This is the negative point. Okay. Again I am telling you that main problem that appears in the use of detergent is that if their hydrocarbon chain is highly branched, more branch is there, then bacteria cannot degrade this easily. Okay. Slow degradation of detergent leads to their accumulation effluent. Just here you understand, branch, if it is highly branched, then bacteria cannot degrade this easily. Okay. And then it will go slowly. Degradation will be slow. Slow degradation of detergents leads to their accumulation. Correct? Accumulation. Effluents containing such detergents reach the rivers, ponds, etc. These persist in water even after sewage treatment and cause foaming in the rivers, ponds and streams, and their water gets polluted. This is an important point. Again I am repeating. Effluents containing such detergent means non-ionic detergent, or any other detergents also which is branched. Okay. Means detergent overall you can tell detergent. This detergent persist in water even after sewage treatment and cause foaming in rivers, ponds and streams, and their water gets polluted. These days the branching of the hydrocarbon chains is controlled and kept to the minimum. Unbranched chains can be biodegraded more easily and hence pollution is prevented. Actually here in synthetic detergent, you have seen that here sulfur they are using. SO3 you have seen. Sulfur is there in a synthetic detergent. Don't forget. And nitrogen is also going to be used. You have seen that is cetyl, trimethyl, ammonium bromide. Correct? But in soap that is the salt form. No sulfur, no nitrogen. This is the main difference. You remember, sometimes main difference will be asked. But detergent has properties of soap, but they are not soap. Correct? Have properties of soaps, but not the soap. They are, because they are the salt, salts of fatty sodium or potassium salt of fatty acid of long chain. Okay, these are the salt. I told you, sodium or potassium salt of long chain fatty acid. There no sulfur, no nitrogen was there. But here in synthetic detergent, sulfur is there, nitrogen is also there. Okay. Then now I have finished your entire chapter of 12th. Already 11th I finished, 12th also I have finished, and also highlighted all important questions which is asked in IIT or medical, even for general competition like UPSC. Also many questions are asked from 11th and 12th. Okay, and some basic things of 12th and 11th, that is also asked in many higher classes like in BSc, MSc. Correct? Even for this CSIR net, in all examination, basic things from 11th, 12th also is asked. Then all things 100% I have finished, and I gone in very details. Generally 58, maximum 52 to 58 class it is finished, but I have taken more number of classes and finished all part 1, 11th part 1, 11th part 2, 12th part 1, 12th part 2, total 4, and I have taken around 350 classes. You can understand how detailed I went, which was supposed to finish in 16 to 4, maximum 240. But due to clarification and many important question, that really a student should know, because sometimes in CT examination, Iitjee examination, also competitive examination, that things are important. Okay, all important things I have discussed, that a student can answer any questions. If they will apply little their mind, then no question will be left. I went in very depth, very details. Now after that I will discuss all, you can say, advanced you can say questions, advanced material I will discuss, especially for IIT and medical. That time that will be little hard, and that because it is advanced, in advanced way I will discuss advanced, that information will be there, hence all things will be not repeated. New things or very little things I will tell about this. All things will be somewhat, so all information will be somewhat different, but basic is the basic. But now next class I will start with especially all engineering question asked in engineering and medical, their answer and explanation I will discuss. I will start chapter wise from the next class in detail, that is advanced information. Some special question will be there, some numericals will be there. Every chapter most difficult questions, most difficult numericals, most difficult answer and which you can't simply answer, then their explanation answer also I will give, explanation also I will give. And almost all question will be university, not university, competitive examination asked question like IIT, like other state engineering questions, medical question, AIMS question, that I will discuss. I will start from the next class, chapter wise I will start, but I will not repeat all the things what I have discussed. 11th part 1 part 2, 12th part 1 part 2, that will be not repeated, that will be extra advance. Little things I will take basic, little things, maximum thing will be advanced. Questions will be there actually. Important question, difficult question, most difficult question, correct, and questions asked in different competitive examination like IIT, medical, AIMS, like that type of question. Okay, next class we will meet. Thank you.